This is 2.2b. What we're going to do here is we're going to continue on with our constant and power rule, but we're going to add one little element of what we're doing here. So before we talked about the power rule, and it's going to work the exact same way for this section too, but what we have to get comfortable with is we have to get comfortable using negative exponents. So we have to understand, one, that if I give you, say, x to the negative 4, that you understand that that is 1 over x to the 4th. But understand, vice versa works the same way as well. So if I give you 1 over x to the 3rd, that is the same thing as x to the negative 3rd. So what's going to happen is when you see something like this where the number, the exponent's on the bottom of a fraction, we need to first change it to a negative exponent and then apply the power rule. Now remember, we are always subtracting from our powers. So if you start with a negative exponent, it is going to go further negative. Okay, so let's just get right into this, and you're going to see a couple of different variations here. So we have 3x to the negative 4th. First off, we can do our derivative. Really easy because we're just going to use the power rule. Negative 4 times 3 is negative 12x, and then this has to subtract 1, so it's going to go to negative 5. Now, if we wanted to rewrite this, we could, and we would rewrite it simply as we would leave the negative 12 where it's at, because that doesn't have a negative power. It would be y prime equals negative 12 on top and x to the 5th on the bottom. Okay, let's go to the next one. So the next one is 1 over x to the 3rd. So in this case, we have to first change it. Now, keep in mind, this is the biggest mistake that many of you will make. We are changing it. We are not taking the derivative yet. We are just changing it to what it's equal to. Notice this is still y equals, not y prime equals. This is y equals x to the negative 3rd. Now we will take our derivative. So y prime will equal negative 3x to the negative 4, and then our derivative will be written as negative 3 over x to the 4th. So the rule of thumb is if it starts as a negative exponent, then your answer could technically be left as a negative exponent. But if it's not starting as a negative exponent, you need to make sure you simplify it to be this. Okay, next one. Again, I'm just trying to make sure that we understand a little bit how this works. So this one's a little bit tougher. We're not really going to take the the derivative here the way you might think. What we're going to do is this becomes a little bit more difficult because it's going to involve a further rule that we're going to go over. So we're not going to really take it, but I just want to show you that this is different than what we have over here. This 3 on the bottom, it is on the bottom. So what we can do is we can technically still take this derivative. We're going to take it like this. We're going to leave the 1/3 as it is. We're not going to bring the 3 up to the top, but we're going to first rewrite it as 1/3 x to the negative 5. So notice the 1/3 stays as it is. So now we can take our derivative, f prime of x equals negative 5/3 x now to the negative 6. So this gets a little bit complicated with where we're at. Keep in mind, our fractions will always stay the same. This right here is technically on the top of the fraction. But what we can do is move it to the bottom. So therefore our derivative here will be negative 5 over 3x to the positive 6. Now the x is on the bottom of the fraction. Okay, so keep in mind when you take the x off from the bottom and make it a negative, it is now technically on the top. We don't write it on the top, we just write it multiplied by our derivative, so that way we can make sure we take the derivative properly. Multiply negative 5 times the top of a fraction, always. Negative 5 over 3, lower our number, and we get to the negative 6, and then we switch it. Okay, so this last one, a little bit different because now the 3 starts on top, so this will be rewritten as f of x equals 3x to the negative 5. So our derivative will be negative 15x to the negative 6. And then we rewrite it, of course, with our exponent as a positive. So negative 15 over x to the 6th. Okay, so go ahead and try this one on your own. Real short section here, but negative exponents usually hang you guys up, so I want to make sure that we spend a whole day only working on negative exponents. So try this one on your own, hit pause, do it. Remember, the old rules are still the same, and then deal with the negatives as you need to. Write it as three separate functions there, or sorry, three separate terms there, all as one function. So hit play when you're ready, and hopefully this makes sense. Okay, so you can see your answer here. Follow through the steps here. So I rewrote it out so that way I have negative exponents for my last term. So this is exactly the same, I just rewrote it. Then I take the derivative. 6x squared for the first one, negative 9x to the negative fourth for the second one, and negative 8x to the negative fifth for the third one. And then I rewrite them, simplifying my signs and moving my negative exponents to make them positive. So 6x squared stays the same, minus 9 on top, x to the fourth on the bottom. Two negatives cancel out, 8 on top, x to the fifth on the bottom. So hopefully that makes sense. If you have questions, obviously let me know on the Edmodo quiz if that's been assigned, or bring them to class. So see you then.